Good morning, students, and welcome to the Google class on intrusion detection system. Your teachers are Prasad and AZHAR. Next slide. Intrusion detection system. With this diagram, we can understand that it works as a system to detect any kind of intrusion is going to take place while the communication is going to happen in the network. Next slide. Content in this session we will try to understand what is an intrusion detection system, types of IDS, how an IDS works, detection methods. Next slide. What is an intrusion detection system? It is defined as a tools, methods, and resources to help identify, access, and report unauthorized or unapproved network activity. IDS detects activity in traffic that may or may not be an intrusion. IDS can detect and deal with the insider attack as well as external attacks and often very useful in detecting the violation of corporate security policy and other internal threats. Next level. Intrusion detection system. There are three types we'll try to understand with this diagram here. One is with respect to honeypot, network based ID, and the host based agent. There are three types of the attacks can be possible here, and with firewall we can able to block them at somewhere we can able to block, and with IDS we can able to detect the any kind of malicious activity in the network, and it is going to be reported to the firewall, and the firewall we can able to have the protection we can able to set here. Next slide. First, host based intrusion detection system. This is implemented on the software and resides on the operating system. It monitors the internal behavior of the host. It will log any activities it discovers to a secure database and check to see whether the events match any malicious event record listed in the knowledge base. Host-based IDS can often critical in detecting the internal attacks directed towards organizations such as DNS, mail, and web services. So here intrusion takes place at the host side, it is called, right? And it is reside inside the operating system. Next slide, please. So this diagram we can able to understand that it is the host-based intrusion detection system is capable of monitoring and analyzing the internals of a computer system as well as the network packets in its network interfaces. So here you can able to observe the packets are coming from the network through the router, it is going to come, and with firewall the packets has been reached, and here the idea is it is going to check the incoming and outgoing packets from the system file and alerts to the system administrator in case of any kind of malicious activity. Next slide, please. Network based intrusion detection system. This IDS captures the information of packets in the network called NIDS, that is network based intrusion detection. Instead of analyzing the information that originates and resides on a host, network based IDS uses a packet sniffing technique to pull data from the TCP/IP packets or the other protocols that are traveling along the network. Most network-based IDS log their activities and report for report or alarm or questionable events. In case of any malicious activities, it is going to be reported in the network. Next slide. This is a diagram with respect to network-based intrusion detection system. You can able to understand that from the host, you can able to get the information from the internet. Right? There are different, this one I can able to understand here from the host network switch connected to the host, and there is one firewall also is there, network router is there to route the packets. So here we have the network based IDS system is available at the network switch side, where it is going to monitor the traffic which is going to be exchanged between the host and the internet. The attacker usually from the internet side it is going to attack, and it can able to launch the attack on the host. And with the help of the network based intrusion detection system, we can able to detect and we can able to alert the host system can be alerted here. It monitors all the traffic which is there in the host. Next slide please. Hybrid intrusion detection system are are the systems that combine both host-based IDS, which monitors the events occurring on the host system, and the network-based IDS, which monitors the network traffic functionality on the same security platform. The hybrid IDS can monitor the system and application events and verify a file systems integrity like the host-based IDS, but only serves to analyze the network traffic destined for the device itself. A hybrid IDS is often deployed in an organization most critical servers. Next slide, please. So this is a diagram you can able to understand the HIDS system, where within the organization we have the servers will be available here. The network intrusion detection system will be available to protect the servers here. Distributed honeypot system also will be available, which is used to collect the unknown network threats and malware samples for further analysis. The idea is here it is detect the known network attacks by signatures and the patterns. So here we have the different types of this one attackers will, whether it may be distributed denial of service, it may be hackers, network worms, phishing emails, etc. are the different types of attackers which may be possible. Hybrid means it is combination of both network intrusion detection system and distributed honeypot. Both are used here. Next slide, please. Anomaly based IDS. It is an IDS detecting both network and the computer intrusion. Use a type of statistical calculation to determine whether the current traffic deviates from normal traffic, which is either limited or specified by the administrator. If network anomalies occur, the IDS alerts the administrators. A new attack for which a signature doesn't exist can be detected if it falls out of the normal traffic patterns. High false alarm rates created by inaccurate profiles of normal network operations. Next line is anomaly based radius. This is one diagram you can able to use here. So starting from the we have the packet filter system is there, where the packets will be sent. The filtered packets will be sent to the database trainer. The abnormal packets will be sent to the alarm generator, and it generates the alarm generator generates the alarm, and it will go to the risk assessment system. The risk assessment system, it is going to report to the intrusion response system, IRS. It is going to be assigned here, and the unknown packets will be sent to the packet classifier, where it classifies the packets as a abnormal packets will be sent to the alarm generator, normal packets will be sent to the risk assessment. Next, the filtered packet which will be sent to the database trainer. Database training will be given as input to the packet classifier. Security database will be secure, where it contains only the important packets which are they will be stored in the security database. Next slide, please. Signature based IDS. It is also called as misuse detection. Monitor the network or server traffic and match the bytes or packet sequences against a set of predetermined attack lists or signatures. Should a particular intrusion or attack session match a signature configured on the IDS, system alerts the administrator or takes other pre-configured actions. Signatures are easy to develop and understand if you know what the network behavior you are trying to identify. However, because they only detect the unknown attacks, a signature must be created for every attack. New vulnerabilities and exploits will not be detected until the administrator develops a new signatures. Another drawback of signature-based IDS is that they are very large and it can be hard to keep up with the space of fast-moving network traffic. Next slide, please. Signature-based IDS. This is example. The packet is captured here and it will be sent to the event processor. From there, it will be sent to the signature matching. So based on that, you can able to identify whether it is a normal packet or it may be an intruder a packet. Next slide, please. This is one more example you can able to understand the signature messages. The automated response will be sent and they have the analysis engine is there which can able to analyze the different types of signatures and the analyst can able to update the misuse model. From there different signatures will be sent to the analysis engine and based on that alerts is going to be sent to the analyst if in case of any malicious activity is there. Okay, next slide please. We have difference between the signature based detection and the anomaly based detection. The data source will be available here. In case of signature based detection, based on the data source, the match pattern is going to be done here by following the different security rules. Based on that, if there is any malicious activity, it can able to generate the alerts or reports is going to be done. This is signature based detection based on the defined security rule. Next, anomaly based detection. So it is going to generate the activity profile from the data source and it is going to detect any kind of anomalies is going to detect. If any anomalies are there, then it is going to generate alert and reports will be there. So this is next slide please. Events of interest to an operating system. So with respect to this, we can have three columns we are going to consider here: variable monitor, event of interest, and possible attack. For example, number of access to a specific file, right? A tenfold increase over the normal term. Then it may be considered as a denial of service attack or a flash event. Login frequently to a particular account, unusually high, attempt to break in. Suppose, for example, if number of distinct source IP addresses arriving packets, if it is very high, then it may be a worm attack, you can call it. Like this, it is listed here, different types of events of interest with respect to the operating system. Next slide. Distributed denial of service, you can call it. Right? So, before going to this topic, let us understand this diagram here. The victim system is available here. Attacker wants to attack the victim and have the different agents will be available and I can able to create different zombie botnets can be created here so that instead of sending only one message, that message is going to be multiplied across the different agents and different botnets and the attacker is going to attack with multiple sources. It is called as distributed denial of service attack or DDoS it is called. Okay, next slide please. What is distributed denial of service attack? Distributed denial of service attack are a subclass of DOS attacks. DDoS attack involves the multiple connected online devices collectively known as botnet which are used to crash a target website with a fake traffic. Next slide please. DDoS assaults don't attempt to breach your security perimeter. Rather, they aim to make your website and servers are unavailable to legitimate users. That is the main aim of the DDoS. DDoS can also be used to smoke screen for other malicious activities and to take down the security appliances breaching the target security perimeter. Next slide please. What is DDoS attack? In case of DDoS attack, so instead of attacking from the single source, there may be a bot header will be there. You can able to use the control server to create a different botnet. Then there may be multiple bots can be created here from the different bots using the internet. The server is going to be attacked here. Right? So here the malicious software first creates the network bots called as botnets is going to be created. It then uses all the botnets to ping a single server at the same time. As the number of pings are far beyond the server's capacity, the server crashes and denies service to its customer. DDoS attacks knocks off web services and network connectivity by bombarding the services with millions of packets within an overload the server's target, making them defunction. The next slide, please. DDoS prevention. There are two methods we will go into. One is preventive measures at the host and preventive measures inside the network. These are the common preventive steps. Buy the more bandwidth, build the redundancy into your infrastructure, configure your network hardware against the DDoS attacks, deploy the anti-DDoS hardware and software modules, deploy a DDoS protection appliance, protect your DNS servers. Next slide, please. Preventive measures at the host side. Right? So one way to reduce the collateral damage is to categorize the IP addresses as most certainly genuine or probably spoofed, etc. Next second point. The almost certainly genuine addresses are those with whom the normal connections were established and terminated in the past. Third one, under rapidly increasing load, packets with unfamiliar source addresses are discarded with high probability. Yeah. These are some of the preventive measures at the host side. Next slide, please. Preventive, next, next, next one. Next slide. Preventive measures inside the network. Attack most DDoS attack packets are proofed source IP address. The first one, address spoofing is employed to confuse the cyber people, making it hard to pinpoint the true source of attack. Second point, perpetrators hope to continue the attack for as long as desired and perhaps even resume it at a later point without being traced. Next slide, please. Preventive measures inside the network. So here method called as egress filtering approach will be considered here. So what is the egress filtering is a practice of monitoring and potentially restricting the flow of information outbound from one network to another network. Typically, it is information from a private TCP/IP computer network to the internet that is controlled. Next, the TCP/IP packets that are being sent out of the internal network are examined via the router, firewall, or similar edge services. Packets that do not meet the security policies are not allowed to leave. They are denied egress. The egress filtering helps to ensure that unauthorized or malicious traffic never leaves the internal network. Next slide, please. So this is the diagram you can able to understand here. So with respect to corporate server and employees laptop, the employees wants to communicate with respect to the server. There is a proxy server will be created and corporate server also will be there, so that the employee data employee request can be sent to the corporate server. Any this one the employee wants to access the legitimate sites, it is going to be allowed through the proxy server is allowed. Next to the corporate firewall also will be allowed. Right? Next, with respect to if employee tries to access any malicious sites, and in that case the proxy server is going to deny this, and at the same time the corporate server also is going to deny the attack. So this is with respect to the egress filtering, it is called. Next slide. DDoS detection. How to detect an active attack on your server. DDoS attacks are quick to start killing the performance on the server. The first clue that you are under an attack is the server crash. With the internet, with the IIS server, the server often returns a 503, that is called a service unavailable error, it is called. Next, it usually starts the intermittently displaying this error, but heavily attacks lead to permanent 503 server responses for all of your users. Next slide. So this is with respect to the screenshot which displays that for any kind of operation we will going to get the same message. Server is not available, that is 503 response will go to get here. Time established, time wait it is going to get here. Next slide. So here in this can you understand that for any kind of request, time wait is going, that is what you can able to get the for any kind of request which is made to the server. It indicates that something you can able to detect the denial of service attack. Okay, next slide. IP traceback. So what is IP traceback? So IP traceback is a name given to any method or reliably determining the origin of a packet on the internet. Due to the trusting nature of the IP protocol, the source IP address of a packet is not authenticated. As a result, the source address in an IP packet can be falsified. That is IP address spoofing also it is called, allowing for a denial of service attacks, DOS, or one-way attacks, where the response from the victim host is so well known that return packets need to be received to continue the attack. Next slide. The problem of finding the source of a packet is called as IP traceback problem, it is called. The IP traceback is a critical ability for identifying sources of attacks and initiating the protection measures for the internet. The most exciting approach to this problem have been tailored towards the device attack detection. Such a solution requires the high number of packets to converge the attack path. Okay, next slide please. Types you can able to get two types are there. IP traceback, probabilistic packet uh, marking. Packets keep track of routers it has visited. Packet logging. Routers keep track of the packets passing through it. Probabilistic packet making. First one. First point. Imagine a router appends a 32-bit IP address to each packet it is going to forward. Second, the internet packet traverses about 10 hops on an average, so 40 bytes are needed to keep track of its path. Solution: compute a global fingerprint for each router, that is the hash of the router's IP address. Next slide. Probabilistic packet making. So here we can able to observe the map of the upstream routers. There are different routers are there, such as A, B, C, D, up to different nodes are there. So each packet which is going to be transferred, the path of the route name is going to be attached here. Map of the upstream routers, and second one indicates the router fingerprint ID field of the IP header is going to be added here. Next slide, please. Explanation for this. In figure A would query about the B, H and G. The router that responds positively, say B, then queries its neighbors C and M. The the one that responds positively then contacts its neighbors, and so on until the source of packet is traced. The storage requirements can further be reduced by use of a space efficient data structure called a Bloom filter. Next slide please. Packet lagging. Router keeps track of every packet that passes through it. The example is SNORET, you can call it. SNORET means it is an open source network based intrusion detection prevention system, has ability to perform the real time traffic analysis and the packet logging on the internet protocol over the network. SORNET performs the protocol analysis, content searching, and the matching operations. Okay. Next slide, please. SORNET operations you can able to understand. A network infrastructure is available here. which captures the packets through the sniffing, and the packets are going to be sent to the preprocessor. From the preprocessor, the SORNet it is going to detect this. The SORNet is going to be added here. It is going to detect and SORNet detection engine and the rule set. Based on that, it is going to analyze the packet. If there is any malicious activity is there with respect to the packet, the alarm is going to be logging, and the same information will be sent to the log file for analysis. Right, this is what the SORNet is going to perform here. And SORNet it is just like a plugin. It is going to be added here for the packet verification and detection operation. The SORNet plugin and the classification of packets will be done through the machine learning operations. Next slide, please. Difference between IDS and the IPS. Intrusion detection system and intrusion preventing system. So what is the IDS? It is detection mode only, and IPS means activate the traffic control also. Next, IDS, traffic replication required. So here original traffic is going to be required here. In case of IDS, decoupling detection and reaction functionalities is required here. So here detection and reaction support is required here. IDS is a good assistant for network administration. So here no administrative assistance is required here, and it requires strict configuration is required with respect to IPS. IDS it is usually used for testing rules. The IPS two network cards bringing is going to be required. These are some of the differences between IDS and the IPS. Right? Okay, next slide. So with that we'll come to the end of the class. In case of any queries, please put in the comment section. And this is a simple diagram either you can be able to understand the difference between the IDS and the IPS you can be able to understand here. So here the IDS is available at the switch side, it is going to be available. For the IPS it is before the switch, it is going to be available, which is in between the firewall and the switch, it is will be available here. Thank you for listening.